Okay, let's talk linear regression. So our next kind of area that we're going to be looking at is linear regression. It's still considered, part of our statistics unit that we look at. It is a bit different, but we are kind of studying still data, and it's still going to be quantitative data. The difference is at this point, we have been looking at one variable statistics, so quantitative data for just one variable. And now we're going to bring in a second variable, and that second variable is going to give us the ability to kind of see if there's a relationship or a correlation, an association going on between two quantitative variables. So throughout this video, it will match your notes, so you can at any time pause if you need to fill in the notes, and I'm kind of moving through the slides too quickly. So we'll first start with defining bivariate data. So the idea of bivariate being two variables. So we're looking at paired data with two pieces of data for each subject. So we have two variables this time. We'll define them as being an explanatory variable and a response variable. So your explanatory variable is going to be your independent input. So just think of any like linear equation, which essentially we're going to get to that point. In a linear equation, your independent input is always x. And then your response variable is your dependent variable, and that's going to be y. So we're looking to see like how x would change or respond to with our y variable. So we're overall going to kind of take a look at like a 5-step process. There's not a whole lot that we have to know about regression, and it's primarily how to use our calculator and how to interpret certain values that we have. But before we even get there, we're going to start to take a look at what these lists are going to look like. So we obviously know we're bringing in another variable, and we're actually going to start with plotting our data. The data for bivariate variables will be used with a scatter plot. So just like a graphical display for one variable data could have been a histogram or a box plot, two variables or bivariate data, we're going to take a look at a scatter plot. So a scatter plot of this data can be used, can be found on your calculator. So we're going to do that, and we're also going to sketch it by hand. So before we do that, let's go ahead and we're going to enter two lists. So we have a relationship, or we're questioning rather, a relationship between a person's height and their shoe size. We have 28 students recorded, their height in inches and then their shoe size. The data is displayed below. So we now need to input two lists. The one list will be the heights. That's going to be our x variable. So the 70, the 68, the 66, the 70, the 71. And then we're going to create a different list to show the shoe sizes. And we have to make sure that we have the shoe size that corresponds with the individual students. So we need it to be 10, 10, 10, that the 70 matches the 10 and that the 68 matches the 10, and so on. So you could pause the video to put those two lists into your calculator. I have done that ahead. So I'm going to have that on the screen so you could kind of make sure that yours matches mine. And then after we input both of those lists, we can find a scatter plot on our calculator. This shouldn't be something that you really would have to do, but something that is good to know that your calculator does it. So if you hit the second button and then the y equals, you get into your stat plots. So you'll notice that you'll have probably most of yours will be turned off unless you used it, but you definitely want to make sure that you only have one on. If they're all off, perfect. Go ahead and hit number 1 and turn it on. And that very first option there is a scatter plot. So your scatter plot will be that first one. We'll never do that second one. There's your histograms. There's your box plots with the outliers. But the biggest thing to realize is that they're asking you for two lists here. So mine were in L1 and L2. So I put my heights in L1 and my shoe sizes in L2. And now I'm going to go ahead and hit zoom. And then I'm going to go down to 9. It's zoom stat. It's sort of like an auto fit for statistical graphs. And there's my scatter plot. So it's basically you're just graphing. For the most part, you're graphing like a coordinate, an x comma y. So a 70 comma 10, 68 comma 10, 66 comma 10. And we should end up with a graph that looks a bit like this. So I'm going to take a moment and sort of set it up with you, and then I'll kind of show you the final, what it'll look like. So I'll have my x axis be my height, my student's height, and then I'm going to have my y-axis be the shoe size. And so essentially the sketch of what we just graphed in our calculator will look like this. Okay, so step 2 is going to be we're going to look at these scatter plots, okay? So we try to look at these scatter plots and we look for certain things. So the things that we look for are going to be direction, form, strength, and always in terms of when we describe what we want to see in our scatter plots, we always need the context. So we've talked about that with one variable stats. We always need the context there. So when I look at this, I notice that, I look for trends, right? So I see the trend in this is that they're mostly following the same positive trend. I could sort of see that they have a bit of a linear relationship. I think it looked a little bit more linear in my calculator than it did here, but just sort of a rough sketch. I could see that it follows a line here, and that most of the points are relatively following the same trend. This one's a little bit odd, but most of them are kind of within that same positive trend that we're seeing here. So when I want to describe this scatter plot exactly, I would say that it appears to be a strong positive linear relationship between a person's height and their shoe size. So direction just being positive or negative. The form is either that it's linear or nonlinear. And then the strength would be kind of how close together or how much they follow the trend. So they all seem to follow a pretty close trend. So I would say it would be a strong positive linear relationship. I got to include my context. And so there's where I brought in person's height and their shoe size. Okay. Next thing we're going to look at is our actual our actual linear regression equation. So just like we were going back here and we were saying, like, it definitely looks like it's following some type of linear pattern. You may have learned this in the past as being the line of best fit. So in a line of best fit, when you've done that in the past, you've seen like a line written there. So we're going to try to get that line. We're going to call that line in IB world our linear regression line. So it's 100%, we're going back to our calculators. And on our calculators, we're going to have to go into back to stat. So assuming that we still have our data in our calculators, which we do, we're going to hit stat and we're going to go over to calculate, and we're going to go down to linear regression. Let's use 4, AX plus B. And my X list was where I put my student's height, so that was L1 for me. My Y list was where I put my shoe sizes, that was L2. Don't worry about a frequency list, we don't have it. We should understand that we don't have a frequency list at this point. And we're never gonna have to store a regression equation. Maybe I'll show you that next class if we have time, but we really don't need it. So go down and we'll hit calculate. So it gives me a bunch of information. The first thing that it gives me here is y equals ax plus b. That should look familiar. It is the form of a line because it is a linear regression, right? So we are finding the line that best fits my data. The A is like the M in mx plus b, it's your slope, and the B is like your B in your mx plus b, it's your y-intercept. Don't worry if you don't have r squared, we'll talk about that shortly, and I'll help you get that on your calculator. In the meantime, I want to concentrate on, I have an A value of 0.354, and I have a B of negative 13.767. So a linear regression line is going to follow that form of y equals mx plus b. So for this set of data, I do have a linear equation, a line of best fit, if you will. That's going to be represented by y equals 0.354x minus 13.7673. So again, this linear equation, it best describes your data with some linear trend that we saw going on. And it could be useful in different ways. Number one, the slope and the y-intercept are meaningful to us, but also it's going to help us understand our R value, which we'll talk about shortly. And it will also help us get predictions, meaning I could input anything for X to help me understand where a Y would be. So I can input any height, and I would understand about what that student's shoe size should be. Before we get to predictions, though, let's talk about each part of this linear regression equation. So we'll start with our slope. So the slope is that A value. It's your coefficient on the X. So we would need to interpret it. So for every additional X variable, that's going to be filled in specific to the context of each question. There is an increase or decrease in the Y variable. Again, that's going to be in context by about, and then whatever that slope is, by about A, whatever the value is. The increase decrease is going to be whether it's a negative or a positive. We had a positive here, so it would be an increase. And specifically, I would interpret this slope as for every additional inch in height, there is an increase in shoe size by about 0.354. Now my y-intercept. My y-intercept is where it hits where a line would hit the y-axis. It hits the y-axis wherever x is equal to 0, which is pretty much how you would understand a y-intercept. So if the x variable is 0, the y variable is about, and it's that b value. So specifically for this one, we had a b value of negative 13.7673. So if a student's height is 0 inches, the shoe size is about negative 13.7673. It's not realistic. We can't have a negative shoe size, but it's not necessarily that that's the shoe size of a person with a height of 0, which also wouldn't exist. It's more that that's what the line would give us, and that line is really just supposed to help us understand about what that trend looks like with a linear relationship. It doesn't have to give us exact values, so it's okay that that doesn't make sense. And finally, we'll talk about the correlation coefficient. So your correlation coefficient is a relationship that we're going to start to look at. So your correlation coefficient will help you understand strength and direction of your data. Okay, so we create this line, and the line has certain distances, and those distances are residuals. We end up with this calculation that gives us an R value, which is the correlation. It's how kind of strong are those values. You don't really ever have to know how to find it. You do have to know how to find it on your calculator. So I'll go back to our calculator for a second. Now I have my R value here. It's 0.729. You may not have it. So if you don't have it, it's likely that your diagnostics are turned off. So before we go any further, let's make sure we have our diagnostics turned on. So if everybody would hit second, then you hit catalog, and you're going to scroll all the way down until and it's alphabetical, until you get to diagnostics on. You're going to hit enter twice. Make sure you're on, not off. Diagnostics on. Hit enter, it'll go to the main screen, enter again. Now it should be good. And unless you ever clear out your calculator, it loses or it dies and you have to change the batteries, it shouldn't ever have to go back. So now you can hit stat. over to calc, down to running that linear regression again. And we're going to repeat the same exact process as we did when we found our linear regression equation. So put in your x list, your y list, and calculate. But this time, you all should have the r squared and r value. We'll never talk about r squared. It's something that you'll do in AP Stats, but not here in IB World. But we will talk about that 0.7298 value. So that's our r value. That's our correlation coefficient. Your correlation coefficient is always going to be a number between -1 and +1. The closer to 1 and -1, the stronger the correlation or association is. The closer to 0, the weaker. It's going to help us explain not just strength, but direction. So obviously the positive versus negative is going to be the positive versus negative direction. And we like to use words like strong, moderate, or weak. So I like to think of strong, a perfectly linear relationship is at 1 and -1. Moderate, I would start to say at 0.5 or -0.5. And then weak would be close to 0. If you're hesitant on whether you should say the word strong, you can always say things like moderately strong or fairly strong, or moderately weak, or fairly weak. And so then we have this interpretation as well. There is a positive and strong association between, and then specifically it has to be, again, in context of your x and y variable. So this one specifically gave us an r value of 0.7298. So I would say there is a moderately strong positive association between height and shoe size. I said moderately strong just because I was slightly hesitant on calling 0.72 strong. So I just bailed myself out and I used a word like moderately to help me not fully commit to being a strong relationship. Okay, so now we can use our model to make predictions. So we have this linear equation. I'm going to use my model to make a prediction for a male who is 67 inches tall. So essentially all I would have to do here is plug in my 67 inches into my x value. So I'm going to do 0.354 times the 67. That's going to give, and then subtract 13.7673. And that's going to give me a value of 9.955. My pen is not working currently, so I can't get that written down for you guys. So I'll repeat that again. So input 67 inches for your x, and then essentially you're just putting that straight into the calculator. So 0.354 times the 67, because that the inches in height is your x variable, plus, minus 13.7673, and that gives me a value of 9.9507. So what that means for me is that if I had a student who was 67 inches tall, I would predict that their shoe size would be about 9.95 inches, or however we're measuring the shoe size. And then finally, things that we have to look out for. So we have to be careful of extrapolation. So extrapolation happens if you're trying to use an x variable that's outside of the range of values that we have for our set to make a prediction. So in other words, if I had somebody that was sort of unusually short in our class, so the shortest height in our class, or in the 28 students that we have here, looks to be 60 inches. So that's 5 feet. So what if I had somebody under 5 feet, right? So if I had somebody at, 56 inches tall, I wouldn't necessarily want to use this equation to make a prediction on somebody that was 56 inches tall, because my data really just starts at 60 and goes up to 78. So I don't have a real good idea of what it looks like kind of before or after these values. So I could use it, but I do need to be aware of it may not be getting me the best prediction, because I'm risking extrapolating my data. And that's it. So you're going to have a practice that basically mimics what we just did. You can feel free to go back to the video and replay any parts, especially in the calculator portion, to understand kind of how to find things. Otherwise, we'll kind of pick up from here and make sure that we're all good with regression on during our next class.